All right, so we're back at OCaml Programming, Correct, Efficient, Beautiful, and we're working on Chapter 3 exercises. We've already done a few. I'm going now. We're on to like potentially harder ones. We'll see how hard they actually are. I'm going to let's see. So this is what we're going to start with. Library exercise, consult the list standard library to solve these exercises. Maybe I won't actually need to. Write a function that takes an int list and returns the fifth element of that list if such an element exists. If the list has fewer than 5 elements, return 0. Hint, list.length and list.int. So why is it saying use the list standard library and then it just like tells you? I guess it's saying you don't have to do these recursively, right? I guess that's their point. It's kind of funny. Okay, so that one should be pretty easy. If we say let fifth L equals or actually maybe no, this is fine. Yeah, we'll go here. And we'll just make this a basic if statement. If list.length L is greater than or equal to 5, it's fine. I guess it doesn't really matter. Then list.nth, what does that take? A list and then the int. Okay. L4 what is it supposed to return if it doesn't exist? 0. I hate that. I super hate that. Now technically this will be interesting to see. Like, how will UTOP infer this? Will it infer it as an int list since I have to return the same type from both branches? I guess it would. That makes sense. The order of arguments of some stdlib functions is so strange. Yeah, I would definitely. I'm just used to list being at the end of all of them, right? That's what I'm used to in Clojure. Is collection comes last, and people. I don't know. People agree with me on that one. Okay, so let's do this. Okay, yeah, that makes sense. I figured it would infer that it's an int list since we have to return the same type from both branches. Okay, cool. Write a function that takes an int list and returns the list sorted in descending order. Hint list.sort with stdlib.compare as its first argument and list.rev. It's literally just telling you how to write the functions. Like, I don't see how this helps anybody. Okay, so what is it? Sort and reverse. Okay, let rev sorted, I guess. Yeah, this is 3 stars, Prophet. like what this dude teaches at like Cornell or something. Like, are college students that soft? Is this the state of the world we live in? Oh dear Lord. Yeah, what's 1 star? Yeah, I don't know. There were a few, but I didn't feel like they were any harder than this. I mean, easier. You know what I mean. This doesn't feel any harder than those were. Unbelievable. Okay, so rev sorted list. Sure. So we're going to say list.sort, and what's the first argument? Is the compare. Okay, stud compare. Is that not how that works? How does stud compare work? Stud lib compare. But isn't stud lib already in? Like, can I just, it's just compare. Right. Got it. I'm good. List.sort compare L. I could do it in Prophet's favorite syntax, which is like this, right? List.rev. I think this will work. Find out. Doesn't need to be 2 lines. Sure. Obviously there's a point free version of this function, but you know. Rev sorted 1, 2, 3, 4. Of course, that's already sorted, so that doesn't really tell us too much. Let's do something real tricky. All right, did we do it? Oh wow, we did it. Do I write Clojure that way too? Yeah, I use threads a lot in Clojure. I used to use them way too much, and then I mean, it was when I was first writing Clojure, and somebody was like, "Yeah, you're probably overdoing it with the threads." I was like, "Yeah, that's fair. That's fair." I got a little excited. I got a little thread happy. And I mean, it's true. I think people do get a little pipe happy sometimes, right? So we could instead write let rev sorted. What is I forgot what the compose operator is in OCaml. What is the compose operator? I forget. It's one of those. All right, let's find out, I guess. What can we do? Revs sorted and then fifth? Sure, we'll do that. Let fifth let FRS. This is how you write production level code. Fifth rev sorted. Doesn't like that. Oh, it's not in std.lib? Are you effing kidding me? It's in, is it in function? But then you can't use it as a, okay. Now I'm just gonna look it up. OCaml compose. Oh, it's just function.compose. I bet that isn't, yeah. Okay. So interesting. Jane Street Core doesn't even, I'm really surprised by this, but I guess maybe they don't like function, they just hate function composition. Unbelievable. Interesting. That really, really surprises me. Interesting. I guess this is just like the common idiomatic way. Yeah. Weird. Okay. Very interesting. Yeah, I think one of the answers there talked about F# using those. Okay. Here we are. Hey Dave, how's it going? Could it be a form of discouragement? It kind of seems like it. We were just talking about how we're surprised that OCaml doesn't have a compose operator. Hey Dylan. So yeah. Kind of interesting. Okay. So we wrote that because I was gonna just do this as I mean, I know I can just use function.compose or whatever, but I was just gonna do that point free, but now I'm not going to because I want a freaking compose operator, okay? Okay, library tests, right? A couple OUnit unit tests. Yeah, that's not gonna happen. Library puzzle. Write a function that returns the last element of a list. Your function may assume that the list is non-empty. Hint, used to library functions, and do not write any pattern matching code of your own. Oh, so they're just saying you still want to do this. Okay, two library functions. Okay. All right. I bet. Is there, like, why don't I have something nice over here that gives me the whole index of everything that's here? Like, why do I have to scroll? Is this just like the wrong way to look at OCaml docs? This is hurting me. Okay. Comparison, iterators, list scanning, list searching, probably this one, right? Okay, yes. Find index, filter, find all partition. Nope, it's not there. Lists and sequences. Okay, I'm confused. Oh, it's probably up here. Cons, head, tail, nth, opt, rev, init. I mean, obviously I could do like rev and get the first, but that's kind of dumb. There's a decent chance that some pages in the manual are older than me. That's funny. Okay. I already forgot what the actual function was supposed to do. I don't need this open. It's confusing me. Just last. Okay. We have a pretty nice name for this function. It's called last enclosure. Let's just see what we have on list. I mean, obviously I can do list.nth of list.length -1, but I just didn't want to do that. I am confused. I just wanted something nicer. I guess that's what we're doing. Okay. Should we do this one as function composition for funsies? fn dot, no. fn dot, is it, do you have to write out function? Is it not called fn? I'm confused. It could be my, it's fun. Fun is the module for function. Okay. Fun. There we go. But it's not there. Why isn't there compose? Is my LSP dumb? Weird. Let me just look in utop. Fun dot const flip id negate protect. Huh. Okay. I'm thoroughly confused, but maybe that's only maybe it's in Jane Street Core that fun composes. I don't get it. It's fine. Let's just forget about the whole point free nonsense. Okay. So this is just list.nth. List.nth takes the L and list.length L -1. I guess I'll probably have to put this one in parentheses just to be sure this actually works the way that I want it to. There's no function compose even in stdlib at all. Oh, okay. I got confused by a Stack Overflow thread then. Okay. So this should work, maybe. We're about to find out. Yay. Okay. That's fine. Write a function any zeros int list bool that returns true if and only if the input list contains at least 1 0. Pretty sure there's for all or something. I guess this will learn me something about the list module. get me more used to these functions. Not like any of this is hard. Probably going to be in list searching. First element of the list L that satisfies the predicate F. That's probably fine. Guess that's what I want. Let's read that exercise prompt again. Any zeros that returns true if and only if the, oh, I think there was a list.exists though. Am I making that up in my head that there is an exists? Checks if at least one element of the list satisfies the predicate F. Okay, there is. We're so good at this. I think it's literally in the hint of the exercise. Let any zeros L equals. I guess this I could do this as this list.exists cycling. Emacs is cycling. List.exists takes the function and then the list. Yeah, so this will work. What do I want to say? Equals 0. What's the easiest way to do that? The fun keyword, probably. Fun. I forget the syntax already. Isn't there like, I already forgot the lambda syntax. It's pretty bad. I know they went over this. I'm just slow. List.exists radicalized you when it comes to implicit side effects. Oh no, what do you mean? Because list.exists flist is not the same as list.exists fun.id. List.map flist. If f performs side effects like binding and unification variable, that sounds terrible. Yeah, that's pretty intense. What was I doing? Not list. Where's the OCaml? What is that called? Learn X and Y minutes OCaml. Here we go. Anonymous. Fun X skinny arrow. Okay. I couldn't remember, okay? I just couldn't remember it. Skinny arrow. Oh my god, I'm being dumb anyway, because I can just use partial application, right? Can I guess I could do that? It's fine. Okay. I'm probably being dumb. Sure. We'll just do this one. Okay. Nice. Nice. So good. Since it's an infix operator, I couldn't do it as partial application like this though, right? Because that doesn't make sense. I have to wrap it in more parens like that. Yeah. Yeah. Okay. So I guess it would be the same thing as this. Is there a more, like, what would be more idiomatic? What would you do, Dave? Would you write it like this, or would you write the fun? It's fine either way. Doesn't really matter. I guess we should just make sure that it actually works. You'd write the fun, yeah. It's pretty ugly to have to use it that way. I don't disagree with that part, even though you didn't even say those words. I decided to. Es muy feo. All right. Okay. Wrong tab. Here we go. really hard exercises. Take, drop. Yeah, what would you do in Haskell, Kinran? Because I know it's similar-ish syntax in Haskell, right? Like as in if you have an infix operator, you have to put parens around it to use it like a normal function. I believe that's how it works in Haskell, if I remember right. Oh, that's right. You can just use equals 0. Oh. Now, is that true for all infix operators or just for certain ones? Operator slices. Okay. AKA it's complicated. Yeah, that's what I'd like to do in Clojure if there was I mean literally in Clojure I would write this as partial equals 0. You know. I would usually do that. But I don't know, the anonymous syntax, the anonymous function syntax in Clojure, while a little bit ugly, is very terse. It's not bad. Where since we don't have a partial operator, you know, you're writing all that out. But yeah. C'est la vie. You can even do it for prefix as well when it makes sense and looks good. Right. Uh-huh. Okay. Yeah, I forgot that that's how it worked in Haskell. I was thinking it was the same. Guess it's really been a while. Oh, there's a 4-star. Let's see how hard 4-star is. Oh, they want us to implement take and drop first. Yeah, if you didn't see my excited tweet about this, apparently take and drop finally made it into stdlib in the list module. I mean, it's been in sec for a while, but Purplish, what's up, man? Oh, and you can also write it the way that I did. Okay. Okay. Take and drop. Got it. I think I know what take and drop is. They want int first, then list. I like that. You're in spotty coverage, but dedicated. get those internet points, right? That's why we're here. Okay, so let take NL equals if list has fewer than n elements, return all of them. Otherwise, you take the first 5. Okay. So how do I want to do this? Is there a function in list that's going to help me here or not really? Obviously, I can do it recursively. But is there another way that makes more sense? I could do it with pattern matching. I could. There's an inth opt. There's tail head cons is empty. Okay. Interesting. You can do tail recursion modulo cons for take. Yeah. It's true. Because there's like a special case. I was just reading about that. I don't know if I like totally get it. It's not like there's modulo in here. It's like a certain way that the OCaml compiler actually am I right in thinking that it's a way that the OCaml compiler optimizes. There we go. I knew I could get the word. Optimizes when you do cons in a tail call or something. I was reading about it and then I kind of forget what it was all about. Okay, let's just do it the dumb way. That sounds fun, right? Oh right, I can't do pattern matching because it's dynamic number. So I guess I do kind of have to do it recursively, don't I? I mean, I could do it with like a fold, I guess, but that'd be kind of dumb. Okay, I guess we'll just do it recursively. Let's take an L. This is the way I would write this function, whether or not it actually makes sense. This is how I'd write it in Clojure if I had to. And the only thing that happens after it is a constructor application. Okay, so then I don't necessarily need the accumulator. So that means that I can actually just write this the like more naive way and it would actually do the right thing. Let's see if I do it right. Okay. If L is less than, no, if, yep, if list.length, meta always taking L's, that's it. Okay, if list.length L is less than N, then we just return L. Oh, I forgot the then keyword. Not used to that one, that's for sure. Then, okay, then L, we're good. Else, length is linear, by the way. Oh, this is so annoying then. Oh, well, it's really effing slow, but we're still going to go this way. Okay. Otherwise, we're going to take... I'm just going to write it this way to start with, because that's how we're going to do this. I mean... yeah, that's fine. I'm really mad right now, but I'll get over it. I guess we'll just take like list dot head. Oh, there's another if case, isn't there? Oh yeah. Then L else if n equals 0. I don't know if this is actually what I want. Then that else list dot head L cons. Just go with this. Take n minus 1. I guess it'd be list.tail, right? List.tail. Is it? I already forgot. I already forgot if it's list.tl or the other one. I could actually type and filter these, but what's the fun in that? Why not just press J all the way down? I bet it's just tail. All right, I got too bored. Okay, it is tail. How about it? Okay, list.head1, take n minus 1, list.tail L. Okay. I guess we'll just put in some parens. And I didn't declare it as rec, because I'm a noob. I guess the whole list.length L is less than n thing like makes me want to have a second function that actually does the recursion so that you don't have like that linear thing. But maybe like, is there just another way that I'm not thinking of that would make more sense? I kind of think I prefer this, but whatever. I wonder what OCaml format would do to my file right now. You only need one if. Like basically you're just saying I shouldn't need the extra branch. If list.length L is less than n. I mean, yeah, that's true. Because here you're saying this would be, so I could do a logical OR here and say, if I just change this to n equals 0, which is that better? Because if n equals 0, then the length, there's a way easier way actually. Oh dear. Let me just see if this works first. How about that? Let's make sure that my take works. Take 2 from here. Yay, it didn't work at all. What did I do wrong? All right. Oh god. Okay, if n equals 0, list.length L. Oh my god, I just returned. No, this is completely incorrect logic. That's what's wrong. All right, okay. So let me just do it the dumb way, the way I did it. Oh my god. That was really dumb. I didn't think through that correctly. Okay, let's try take 2 again. Yay, take 2 works. Hey, Merrick, what's up? Okay. So my naive way of writing this is correct. Now you're saying I only need 1. Let me just think about this. Okay, so if I say take 5L, I return the list. Yeah, totally. Welcome. We're doing some OCaml today. But yeah, thanks for joining. We'll I always say that apologetically to people that I know are rusty people. We're doing OCaml. I'm sorry. I apologize. But yeah, it's all good. We're having fun. And I'm not even skill issuing with the language as much as I am skill issuing with like thinking, my brain. Okay, so apparently this is too complex and I could write it simpler with one if, and it's a way easier way. Let me think about this for a second. If list.length L is less than n, then L. Okay, that's like our if condition, sure. Like we have to return the whole list there. Okay. I mean, I guess I was trying to short circuit it, but since list.length is linear anyway, there's no point in short circuiting it. Is that the point, Prophet? Like if this was constant, then it could be like worth it from like a perf perspective, right? To like short circuit. Okay. Okay. All right. So we just don't want to do that. And instead of saying if n equals 0, okay, let me just think about this. If n equals 0, Or, yeah, okay, got it. Or list.length L equals 0. We have no other things to take. We can't do anything else. We just have to give it an empty list. And that's our base case. Okay. Let's just say take 5. Yay. Yay, I know how to code things sometimes. Okay, and then let's just do drop real quick. Okay. Let rec drop in L. Drop's interesting. I know, right? Thanks. So good at this. So I guess our base case is that n equals 0, right? So we say if n equals 0, then we return our thing. Is there... I don't know if there's a way to do drop in a way that I would like. Well, there's not, like, I'm just returning the list without the thing. I just am trying to get to... Yeah, then L. I'm being dumb. I'm being dumb. Don't tell me what to do. Okay. Else, all we have to do is say drop. Oh my god, drop's so easy, isn't it? It's so easy. List.tail L. Okay. I'm glad I did this. We'll see if this actually works. It's so easy and then it doesn't work. That would be so like me. Now there is the problem, like if what happens, there's a case I didn't handle. What if I do this? And what if I do drop 5? Yeah. Thought that might happen. Okay. So I just didn't add a second case in here, which is, again, if list.length L equals 0, we just return an empty list, right? And then drop 3 works, and drop 5 still works. Okay. So OCaml is a lot more idiomatic if you use pattern matching instead of head and tail. That makes sense. That's true, because if I did these as pattern matching instead of head and tail, let's do a take prime. Can I use this syntax with rec? I imagine I can. Then all I have to do is say h const t. It might help if I put the guard. Take because I have that extra in argument, it's not just going to figure that out, is it? I guess I'd have to do it as like a tuple. No, I think this is a bad way of doing this. Okay, let's say take NL, because I'm not smart enough to figure out how OCaml is going to do that. And we'll just match this like a tuple, match with, and here we're going to say n comma ht. You have 6 uses of list, head, and Polaris, and almost all of those are on argv. Oh, that's funny. Okay. nht. It's not that hard, guys. It's not that hard. I'm telling myself, of course. And then I can just do T. And then, but this doesn't, I guess I need the other guard case first. So what? Maybe something like this. No. That. See if that works. Take 3. Nope, I did something wrong. What did I do wrong? They really are pretty. I'm pretty sure my base case is right. Is it not? Let's see. If we're at 0. Oh, I forgot to cons. I forgot to cons the whole effing thing. Oh my god. I forgot to actually, you know, like create the output. Okay. That would do it. That would absolutely give you a an empty list no matter what you did. Okay. There we go. Now we know how to do things. Yeah, that is really pretty too. It is a really nice, how do you not love pattern matching, you know? Okay. So I guess my question, is there the whole function, special function syntax without, like, is there a way to write this with the function guard, the function keyword, instead of this way? Like, does it just pretend that it's a tuple or no? You want to see if it makes the first take I did? Yeah. Only works if you have one argument. Okay, that's what I was thinking. Okay, so I need the match. Thanks. Okay, cool. Take in L. Okay. Let's just write drop in terms of match to for funsies. This is actually helping me a lot. This is helping me learn the world quite a bit. It's going to be similar in that we return L else N HT. Haskell has a proposal for cases that works how you want it to. That's cool. I just thought it might work because of how OCaml does their weird multi-value fake tuple, real tuple thing. Okay, nh cons t drop in -1 t. Yeah, that is a lot nicer, isn't it? I really like that. It's pretty. Not bad. Okay, let's just make sure it actually works. What? I named it take again. I named my drop prime take prime. You take prime and you drop them. Just kidding, prime. Just kidding. Okay, drop 3, 1, 2, 3, 4. Should give me 4. Drop 2. Drop 5 should be empty. Beautiful. I guess I should also try drop 4 just in case I'm dumb somehow. There we go. Yay! Those are nice functions. OCaml really is beautiful. All right. What's up, Nunez? Do I recommend? I don't know, man. I don't recommend very many things. That's really cool. That Haskell did that though. Yay. Okay, so we did take and drop. Revise your solutions for take and drop to be tail recursive. If they aren't already, test them on long lists with large values of n to see whether they run out of stack space. To construct long lists, use the dash dash operator from the lists section. I don't remember what this does. Building lists. I already forget how it works. Dash dash. I guess we can search for it. Yeah. It is. I don't know if it's that one. It's pretty much that one. If you're saying, I think CS3110 is great. It's very verbose, which I don't always like, so I skip things myself. But I think it's been great. The thing that I was surprised about, because I'm actually reading real world OCaml on my phone just as I have like a few minutes to spare throughout the day, is real world OCaml follows core, which is like Jane Street's standard lib, where CS3110 uses stdlib. So to me, that's another reason to use this. Yes, that's awesome, Prophet. That's hilarious. What's up, Whimsically? How's it going? Haven't been able to catch any of your beautiful BQN lately. So this basically, he just defined this operator. It's not that actually exists in OCaml. Okay. Right? Okay. Didn't think so. But I can just do from 1.5 like this, apparently. Oh no, he defined the whole thing. For some reason I was thinking there's a way to do this though. Is there not like a range or anything? We don't have range. Beautiful BQN, yep. You just want to say Leo and Dylan loves me more than you. They gave me VIP. Nice. I mean, I'm a mod in Dylan's stream. But it's easy to not like me. I get it. Okay, I guess we'll just use his functions for funsies. I'm not gonna do his operator thing. List.drop. Sure. List.take 1000. Okay, let's do a let so this doesn't print out something stupid. Let L equals list.take 1000 from 1 to 1 million. Seems good. Here. Oh my god, I did list.take. That's hilarious. This song, I'm sure, is Russian Circles. Melee by Russian Circles. Like that. No accents. Okay. Russian Circles is great. Really easy to listen to while coding and stuff. Doesn't distract you with lyrics. I have some really, really good sounds. Okay. I already forgot what I was doing. Unbound value. Oh yeah, right. There's not a real one. There's not a real one. So let's try a couple of these and see what happens. Well, first of all, let's maybe do this and say, let's call this a BL from 1 to, let's just do 10,000. I mean, this is an Intel MacBook after all. It still prints it out anyway, doesn't it? Okay, good. There's the ellipsis. I didn't know if UTOP was going to do that or not. Okay, good. And then if I say let L equals take 1000 from BL. Okay, I'd say that's clearly tail recursive. I would think. I think we did okay. I don't know. I'd say on 10,000 items, we're probably safe. To assume that that's tail recursive. List.length L until way later. Okay. I guess I would just assume based on how quick it happened, but I could be wrong. I could be wrong. You know, it's good enough for me. All right. Revive zero solutions. Oh, that's what we already did. Okay. We don't even need to. 4 stars is just to make a recursive function tail recursive. Like a really, really effing simple function. Tail recursive. I don't get it, man. It's fine. It's fine. Unimodal. Write a function is unimodal that takes an integer list and returns whether that list is unimodal. A unimodal list is a list that monotonically increases to some maximum value that monotonically decreases after that value. I don't understand. Is this normal language? I'm guessing it's like 1, 2, 3, 4, 5, 4, 3, 2, 1, but it could be any step. So it could be 2, 4, 6, 8, 10, 8, 6, 4, 2. I think that's his point. I don't know what he means by monotonic in this case. I've never come across that. The n+1th element is greater than or equal to the nth up until you hit that element, and then it flips around. It is a math thing. Well, we know I haven't studied math in a long time, right? Until you hit, I don't understand it, so I'm not going to implement it. I still don't like. I mean, I get your explanation, but I don't like completely get it. And then it flips around. I still don't get it. It's fine. It's fine. I'm just moving on. It just means that the elements never get smaller. Interesting. But it doesn't mean that the list is balanced, right? Like the range of numbers doesn't mean that there's an equal drop off. I guess that's not what he's saying. Oh, you're right. Okay, I get it. He's not talking about whether it's equal. It's just basically every number is going up until we hit a number. So once n+1 goes down, we have to make sure that n+1 always goes down. So basically n+1 should always go up until it doesn't. And then it should always go down. Okay. All right. I got it. I guess we can do it. Let rec is unimodal. L equals This is actually where I feel like I don't want that to be my rec, because I need to like keep track of the number, don't I? Let me think about it. Typically what I would do is have another function like, I don't know. We'll just call it mono for now. And I might just have this be, okay, let's just forget about this for a second. Obviously I could use the function syntax here, but we can change that later once I actually write the function. There is a concept strictly monotonic that means no equal number, only increasing sequence. Okay, cool. Thanks, guys. I appreciate it. All right. Come to think of it, I haven't checked my messages in a while. Whoops. Hope everybody's okay. No, I don't want to edit my emergency information. I'm trying to effing get into my phone. People. Okay, so yeah. All good. So how would I do this? A constant list is unimodal, as is the empty list. Sure. So if we have an empty list, then it's true. If we have H, well, let's just do this. Let's say FS this. I guess the other one that's true would be that, right? I think that works. If it's just a list, or yeah, I think that works. Otherwise, if we say fs t for tail, then what would we do? I guess you have to like decide whether you're on the unimodal, if you're on the increasing or decreasing path at this time, right? So writing this in one function will be a little bit annoying, if not impossible. Yeah, pretty sure it's more on the impossible side of things. Okay, so I still might just leave it like this though, and then just like, I don't know, do something like this. Where we have unimodal fs t, and then we should probably, we could pass it like a comparison function to know like where we're at. We could do that. So I could do something like it has to be greater than or equal to, right? As one of the functions, and then that will change. Let me just think. I guess if it's like this, then we want this. I'm trying to think if I actually care about what these are. I guess I don't. We'll just go with this for now. Let rec unimodal. We'll say f or maybe C for comparator L equals match L with and what do I want to do here? Match L with, is this what I want to do? I think so. Oh, I'm going to have to do this anyway. So now that's not necessarily true here. Okay. Let me just think about it. I guess I just need to do my other logic first because I'm not thinking very well. Let's just put this back here. And basically, I would say CFS if CFS. Oh, I can't actually put this here, right? If CFS, can I do that? Or is it when? Is it when? Am I like completely off? Let's just do a catch-all for a second so that hopefully this goes here. It stops lying to me. When CFS, then what do I want to do? I think I just want to do unimodal CL. Unimodal CL. Okay. Oh, this is a little bit annoying. Does this work? I keep trying to write Lisp. Is this true? Nope. That doesn't work. So I would have to have some sort of like symbol instead of just passing the function to know when I'm supposed to go back to the other one. I hate this. This is why I don't delete code stuff. I know this is simple, but it just annoys me. My brain just doesn't care enough to actually solve problems like this. Oh, dear Lord. Okay. Match L with FST when CFS unimodal CL. Maybe. I think that branch is actually fine. I think that is, except not the T, not the L. It's supposed to be T. Actually, no, it's not supposed to be T, is it? No, because we still need to know the next one. So I think just the arguments to this suck. I think that's part of the problem. So let's say CF. I guess probably what I would do is I would have like a last. We'll just call it last. And then we'll have our L. And then let's just say last L. And maybe the pattern matching is actually confusing me and I should just write this with a list with ifs for now. I think I would like to do that. I think that's what I want to do. Love it when I miss one. Okay. I'm just going to write this with ifs because I'm confusing myself. Try to solve example 1, 2, 3, 4, 5 and 1, 2, 4, 3, 5. Yeah, I mean, it's not that I don't have the examples in my head. I mean, it's literally that I just sometimes don't care enough to solve the actual problem. But yeah, it's fair. We'll do it. 1. I can't type. That's the other problem. 1, 2, 4, 3, 5. It's false. This is true. Okay. So let's just do this and we'll say F. And I guess we'll have to do this. No, we can just do this, and then even though it's kind of dumb, we'll just do it this way. We'll say F, and then we'll say list.tail_L. Okay. All right. You want to backseat me? Just give me a second to see if I can work something out. And then you can backseat me. There's plenty of ways that I'm just not good at this. You're really good at these two, Whimsically. You're so good at them. When I saw you solve Advent and Code, I was just like, oh my god. But just aren't the things I'm the best at. Give me like a real world thing, I do a lot better. But for whatever reason, these little problems. You got gifted a very expensive shaving brush. Really? What's that like? Okay, if C is less than, that's hilarious. If C last, let's just do this for now, even though it's dumb. List.head L. It's the only thing you needed to grow a beard. As magnificent as mine. There you go. Yeah. If C last list.hdl, then so if the last element that we had is greater than or equal to the first, that's not actually our problem anyway. This was actually wrong anyway. It was supposed to be list.head last. There we go. Then what do we want to do? We want to keep going, I'm pretty sure. Then we're probably going to do unimodal. Yeah, this is really ugly, but just bear with me here. List.head L is our last. We need the C, and we need list.tail L. Okay. Why would that be easier than pattern matching? I don't know. It's not. That's really what it comes down to. It's not. And it's more expensive than you're comfortable with. So you really have to do the right thing. Okay. I guess we should have this on its own little line for funsies. If C list.head L last, then unimodal C list.head L list.tail L. So this is all good, except, and like this would return true for 1, 2, 3, 4, 5. it would never have to switch over. If C is not that, then we need to change the function that we're passing to unimodal. But this of course won't work because it won't. Right. Then we're just going to pass the exact same arguments. Yeah. So let's just say last and L. Okay. So obviously this would infinitely recur. I'm aware of that. Okay. So I think what I want is like some sort of symbol, like enclosure. I'd probably use like a keyword here or something like that I could match on, blah, 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 to know whether I'm supposed to be going up or I'm supposed to be going down. Probably what makes... I could do that. Or I could like have this not figure it out and change. And I could just do like monotonically decreasing instead. So I could be like, what? Mono deck and then do the whole thing. I don't know what's nicer. Stack Machine might help if you think of the problem that way. I think this pattern match in Stack Machine will work pretty good to solve this program. If OCaml's pattern matching is similar to Haskell's for list. Yeah, it's very similar. I think it's a little funny that this is a 3-star exercise in some ways, but maybe like this is a lot easier to everybody besides me. Would you rate this as a 3-star when drop was a 3-star? Maybe it's just that I understand fundamentally, because I use it all the time, how take and drop works. And I don't ever check if a list is monotonic. Okay, it's not just me. I appreciate that. For a beginner. Define beginner, Emmy. I can ban you. I can ban you. Oh, for a beginner. Okay. How do I want to do this then? Yeah, I think having 2 functions works better for me. I'm just going to go with that. We'll see how much I hate it. So instead of this whole thing, we're going to say mono inc. Of course, F is usually function, isn't it? We could go with this some more, but I might not actually need all of that. I'm not a beginner. I'm a manager. I am not a manager. Do you really think I'm in management? Did you think I was in management? I'm certainly not in management. That is so insulting. All right. I think I can do this then. Let me think. Can I do this without the other thing? I don't think I need the other thing if I'm doing it in 2 functions like this. I don't think I do. Let me just play with this for a minute. So if we say first, second, tail here, when second is greater than or equal to first, then we should be able to just say mono inc second const tail. I mean, it's not, that part's not great, but it's fine. Okay. Now, what else? If we have all of this, then we might want to go to monodeck. And I would call monodeck with the exact same list. That could be cleaner just in a single branch with a simple if else. I don't know. And then if we have first an empty list, or I guess if we have an empty list, I don't see why that would happen based on the other arguments, then we can just return true. Because we've already checked that. I think this would work. Let's just test this as a very, let's make a mono inc prime real quick. And just test this on our non-deck case and just make sure that my logic actually makes any sense. And then we'll go from there. Of course, the cons thing might not work the way I want it to, so I guess we should put that in parens just to be safe. Is there something else that you hate about my function, mister? There's something else I did wrong? Oh, I didn't use mono inc prime here. That is a problem. Variable FST must occur on both sides of this pattern. Oh, just me being silly. Okay. Why don't you like me? Oh yeah, we might want, it's just possible. Yeah. Nope, I deleted the when and I wasn't supposed to. That's on me. When second greater than equal to first. Okay. That was on me. And then we have our base case of false. Okay. But something's still wrong. What did I do wrong? Unbound value tail. Yep, that'll do it. But that doesn't seem like that's actually, oh, I know what I did wrong. I used function matching syntax when that wasn't there. Okay. Okay, so mono inc prime with 1, 2, 3, 4, 5 is true. If we did a 3, it should be false. Okay, so we can be pretty sure that this works. I really wish you didn't have to put separators in lists. It would make me happy. But I know white space doesn't mean anything to OCaml. All right. So mono ink looks fine like this, which means the main thing I need to do is do this and do false. Well, I guess this actually might not be necessary. Because there's never a time where none of those things are true. I think it's already exhaustive. Okay, so that means, first of all, oh, that's funny. I did function syntax and then I used L by itself. It's kind of silly. I mean, I could do it and then just cons them back all over again, but that's kind of silly too. I don't know which one's better. It doesn't really matter. We'll just move forward with this. Who knew this would be the one that really screwed me up? When second is less than or equal to first, then monodec second tail. Okay, so this should basically be the same there. I think, yeah, no, that's fine. Else, you just think about that. That still has a tail. I guess that, oh, that could be a logic error. Let me think about this. Let me just think about this for a second. No, because it's already checked. It's already checked. That's why it's not a logic error. I already thought about that. So we're going to say that's true. And then we're going to say else false. Don't know if this will actually work. Okay, what don't you like about this? This expression is type A list, but an expression was expected of type A. Okay, okay. Do I need to do this? Is that the problem? Yeah. Need some parens. Might help if I like actually just called all these T's tails. I guess it's weird that it didn't error on that one. I bet it's about to. I bet it's about to error on that one. Huh, it didn't. It's weird that it didn't say that all these things don't appear on the right side of this match like it did before. Is there another error in the file that's stopping that? Probably. Okay. Probably more verbose than needed, but it's something. Let's see about this. So let's just do that. And then, oh, need to check this message. 1 second. All right. Need to go pretty soon. Anybody think this is actually going to work? It's looking pretty good so far. Okay. I didn't actually think I was going to get it first try. Let's try a couple short lists. I mean, I guess technically 2.1 is also unimodal. Or should it actually be false? I don't know. It's just 2 is the actual peak in that case. I don't know about that case. It's not exactly pulled out. Unimodal matching mountain triangular like curve, first increasing then decreasing. Yeah, basically. This is true. Okay, hey, that wasn't so bad. Let's see if there's something I want to do. This one just works for monotonically increasing lists. Let's see. So because we're already matching in mono inc for one element lists and empty lists, we actually don't need this at all. I mean, we could actually just make mono inc the is unimodal, but I don't particularly like that. So I would probably do it like this, where I actually just do something like that. And all of our examples should still work. Yep. How about it? That's not so bad. Would you guys have done something different? I don't know if I'm going to do another exercise. I thought I would just go through all these exercises quickly, but this one really tripped me up, and sometimes just really simple functions still trip me up sometimes. Just happens. Hey, what's up, Nightshade? I just got skill issued pretty hard. Not in OCaml, but in thinking. So that's kind of where we're at. Morning. Did you move to Australia? Yeah, the problem and solution is both very simple. I think what was the part that I was overcomplicating? I think the part that I was overcomplicating was wanting to do it in a single function. And that was just like a gross way of doing it. But literally just breaking it out into one function's checking whether it's decreasing and one function's checking whether it's increasing makes it a lot nicer. So there's that. Maybe there's a nice solution using one function, but it's not apparent to my head. So that's how it goes. Maybe, maybe not. You'll never know, right? Nightshade is now an Aussie. Got it. All right, let's see if I want to do this or if I want to raid. There's a lot of effing exercises. There's a lot of exercises in here, but they have actually been kind of useful for me. Besides the thinking part, just like getting used to the language part, it has actually been pretty nice. Write a function power set. It takes a set S represented as a list and returns the set of all subsets of S. It's too leak code for me. I don't care about you. This isn't going to teach me OCaml. This is going to teach me thinking, and I'm not here to think. All right. Print int list rec, write a function, print int list that prints its input list one number per line. Okay. Here is some code to get you started. Okay. I mean, it's just print in line. It's literally this print in line H. Why is this even an exercise? Okay, fine. Write a function print int list whose specification is the same as print int list. Do not use the keyword rec in your solution, but instead use the list module function list.iter. Okay. Same thing. This is just print in line. I don't think that's going to help. You arrived at the perfect time. Oh no. What is this going to be? All right. Brave is set. What's up, Leandro? Yeah. I don't need all that thinking stuff. Okay, so again, that's just print in line. I don't think that's very helpful. So literally it's like a 2-star for when you're printing something. Like you're iterating the list and printing it. And it's a 3-star doing this whole like monotonic list check. It's fine. I don't get it, but it's fine. Assume the following type definition. Type student, give OCaml expressions that have, yeah, I don't have to do thinking. And a 4-star for making a function tail recursive. Exactly. Like, that's just such a weird ranking of difficulty. But like, maybe I'm not, and you don't count profit, but like, maybe I don't know what it's like to be, I guess a second year CS student. I don't know if I don't know if the number means anything. Like if it's CS3110, does that mean you're a 3rd year CS student because CS programs in the US are 4 years? I really hope not. I don't know. I don't get it. It's fine though. Yeah, he's all about the Pokemon. All about the Pokemon. All right. Give OCaml expressions that have the following types. Student. Okay. Student string, a function that extracts the student's name. Okay. And string float student, a function that creates a student record. Okay. I'm not going to bother doing that. Poke record. Here's a variant that represents a few Pokemon types. Define the type Pokemon. Pokeballs. That's hilarious. I like Poke. Poke is really good. Okay, here's a variant that represents a few Pokemon types. Normal, fire, water. Define the type Pokemon to be a record with fields name, HP, and P type. Okay, not going to do that. Create a record named Charizard of type Pokemon that represents a Pokemon with 78 HP and fire type. Okay, we're going to skip that one. That one's easy. Safe head and tail, write a function, safe head that returns some x if the head of the input list is x and none if the input list is empty. Sure. I think we'll pass on that. PokeFun, write a function max HP. Pokemon list, Pokemon option that given a list of Pokemon finds the Pokemon with the highest HP. Sure. We could do that, I guess. All right. I mean, I would just end up doing it recursively though, which is fine. Is there like a nicer way of doing that versus just writing a recursive function? There's probably not like a, I mean, you could write a comparator function and then write a max that takes a comparator. Recursion is its own reward. Yeah. Okay. I guess I'll do this one and then we'll call it a day maybe. Let's see. Is there a better exercise? I don't like dates. Who wants to do dates? Nobody wants to do dates. Earliest date. Okay, so these are all very similar. Use the functions. I'm going to do one more exercise today. I don't care about association lists. Do you ever actually use a lists, Leo? Yep. All the single people in chat hiding from dates. Hilarious. Rarely, yeah. I could imagine using them here and there, but like for the most part, not. Yeah. Yeah. I don't disagree. Like, yeah, you just make a record. Yeah. That's what I figured you would do, is you would just make a record because you might as well have that, or you do a hash map. Like, yeah, in Clojure, like we just use hash maps all the time. You just mean it'd be better if you define actual record types instead of using hash tables. Yeah, that makes sense. Profit. Oh no, they're immutable. Okay, yeah. I always forget that that's a thing. I have the opposite problem of coming to OCaml, which is I forget that mutability is possible. Maps are the immutable hash tables. Okay, got it. Everybody's like, oh no, immutability. And I'm like, mutability, what's this? Use the functions insert and look up. Okay, that's more A-list stuff. Define a variant type suit. Okay. Define a type rank. Define a type card. Define a few values. I mean, that's an okay exercise. Let's just do the max HP thing. Oh, but then I have to implement all of the other things. It's really annoying. I'm just gonna new type. This is what I'm gonna do. I always say new type. Type alias. Type Pokemon equals. It's going to be int star string. Okay. Let's just do that. And then It's just a tuple of HP and name, basically. Should we do this? Poke name equals string, and then we can be like really cool. That's totally worthwhile. Good thing I didn't just make a record type. That would be a lot harder than this. All right. I'm being silly, aren't I? But then, oh yeah, you get structural typing. I don't have to do hard things. I think I'm actually still going to do it the way I was going to. Ham, avocado, miso tuna. That doesn't sound like the best sandwich in the world, to be honest. Okay. I'm going back to my type alias tuple. And this is supposed to take a list of Pokemon and return a Pokemon option. Oh god, the time went by. I have to leave in like 10 minutes to go pick up my kid. Given a list of Pokemon, finds the Pokemon with the highest HP. Okay. So this is just your standard max function, right? So we would do something like let max HP L equals like actual max here. We could do something like let is max, which takes a current max and an L, and then I guess we can't call that max. We'll just go with this. We'll go with this as our recursive function. Match L with guard. Yeah, I think that's how I want to do it. If it has one element or it's an empty list, then it is just the first element in the poke. Oh, I guess empty list. What is it? Oh, it's returning the actual Pokemon. I forgot. So max is actually the Pokemon. So I guess we'll just say max here. Oh god, I hate this function so much that it's returning an option right now. I guess I'll just make this a little bit less annoying. I'm just going to do this to make this a little bit easier on my head. Okay. And then we can say something like P1, P2, tail, and how do I want to do this? I guess we could just do this. Is there an as syntax? There's probably not. I guess we can just create it again. HP1 N1 HP1 N2 HP2. Oh my god, I'm using type syntax instead of the commas. Silly. And then is there like an int.max or something that I can use so that I don't have to do something dumb? Int.max. Okay. 1, 2 returns 2. Good. Oh, but then I have to. All right, I guess we'll just do 2 things, even though it feels really silly. N1 is greater than N2. I guess we'll just say greater than or equal to N2. Then we will. Oh, why am I doing it this way? I messed up somewhere. And I don't have time to really finish this. Okay, let's just finish this thought, whether or not I should. First of all, this has to be a sum p. And then if N1 is greater than or equal to N2, then we could call isMax. Oh my god, what did I do? IsMax N1 HP1 with tail. This is one way to do it. I'm not saying it's a good way to do it, but it's one way to do it. All right. And then can you tell I kind of suck at algorithms? Just a little bit. Just basic ones I sometimes suck at. If it's less, then we're just going to make this R2 and R2 and on to tail. Now, the thing that doesn't make any sense at all, of course, is that like once I get here, I shouldn't return none. I should be returning max. And here, if there's only one element, that should only happen at the very beginning with the way that I did this, even though that doesn't exactly make sense. It's not usually how you would do this. Because I'm not even comparing it to the max. Yeah, I just completely fucked this up. Nope, I fucked this up pretty bad. This is really silly. This is a really silly way of doing it. Yeah, I'm doing terrible at speedrunning it, but it is a good idea. All right. So let's just match max L. Sure, we'll just shadow that. And then this should be actually MHP. And then comma speed walking, speed typing. That's right. And welcome, wizard. Okay. This is actually how you would usually write a max function. Let's just pretend I didn't write those parts. Okay. Where you just compare your current element to the max. You don't actually do all this weird like list traversal stuff. PN, PHP, oh my god. Oh no, what is this stream? What is this stream coming to? Okay, sorry about that. All right, MN, MHP, PN, PHP on a list. Okay, yeah, all good. So except This is actually just tail. Okay. And then when we get to the end of the list, all we have is max, and we return max. Okay. And then this just goes is max none L. Okay, that makes sense. And this becomes if PHP is greater than, yeah, we'll just keep it as greater than MHP, then is max we're almost there. We're almost there. Just give me 1 second thinking about it. Okay, PN PHP tail. Else is max tail. Okay. That's probably right. Yeah, it definitely has a lot of Haskell vibes. For sure. I guess my question is, would you usually put this in an if block, or would you just do it in a new guard and you just do when? Would that be more idiomatic to write this like this? And then we just have another guard. I already know, actually, in this case, that max is greater. And so then I don't care about this. And I just care about the tail. This is already looking better. I already answered my own question. Whether or not it's more idiomatic, that's a lot nicer. Yeah, that's a lot nicer. Okay. Why do you hate my none down here? Did I... Oh, the expected type is A star B. Oh, that's hilarious. It's not really, though. It's not really, of course. A. And I just have to rewrap this. Lots of parens. That means it's 4:30. And that means I really need to go. All right. All right. Let's just see if we can test this out real quick. What did I do wrong? I did something wrong. Oh, this is what I did wrong. This isn't actually an option. That's what I did wrong. Yeah. So all the rest of this actually works fine, but that's not an option. There we go. Let's see, max HP. Let's try a list of A, 5, B, 3, and C, 2. Let's see if this works. It got a none. I totally fucked up somewhere. How the hell did that happen? Did I forget? Did I forget how this works? I guess I didn't. Oh, I didn't handle the case where max is none. That's what I didn't handle. So there's a third case. Hey, what's up, Des? I am just about to raid, actually. But welcome, and hope you're doing well. So let's just say this is none. This is just our first poke. And this is our tail. Then we'd say is max sum first tail. I think that's what I did wrong. Yep. That'll do it. Let's just add one more. Let's make this 6 and make sure that it has not some positional bias. Nice. Hey, you know, I'm a little slow sometimes, but I do know how to code here and there. Let's find somebody to raid. Thanks so much for hanging out.